Okay, good. A very good day to our fellow friends and our lecturer, Sir Muhammad Hazim Fahmi. Today we are going to present about the use of vector in engineering. Our group consists of four members, which is including me, myself, Bernard, Patricia, and Lawrence. Yeah, next slide. Okay, so what is vector? A vector is an object that has both a magnitude and a direction. The cross product of A and B of two vectors is another vector that is at right angles to both. Next. Examples of vector. It can be used for a wind, a boat travel, for some physics. For other examples, it can also be used as a to find the direction of in for example, for a ship from one land to another land for them to reach another which is a certain distance. Okay, and then um, for a weather forecast and other scientific uses of vectors. Next. Um, okay, so here I'm just going to cut it some of it. Okay, so a vector is a mathematical object that has magnitude and direction and satisfies the laws of vector addition. Vector addition. Vectors are used to represent physical quantities that have a magnitude and direction associated with them. For example, the velocity of an object is a vector. The direction of the vector specifies the direction of travel, and the magnitude specifies the speed. The force acting on an object is a vector. The direction of the vector specifies the line of action of the force, and the magnitude specifies how large the force is. Other examples of vectors include position, acceleration, electric field, electric current flow, heat flow, the normal to a surface. Okay, next. Okay, and at first look at vector composition practice, we almost always describe three-dimensional vectors by specifying their components in a Cartesian basis. Specifying the components of a vector is a lot like stating the position of a point on map. For example, we wish to specify the position of Long Island Airport relative to JFK Airport on the map below. We might say that MacArthur is 33 nautical miles east of JFK. Just like what I said just now, it is used to find a certain distance from one place to another place. Okay, so that's all from me. Okay, I'm going to leave this to my next colleague. Will you take care of it? Thank
All
you.
right. Thank you, Dennis. So for me, my part is application of vector in engineering. And here is the example. Okay. Vectors are used in engineering mechanics to represent quantities that have both magnitude and a direction. Many engineering quantities such as forces, displacements, velocities, and accelerations will need to be represented as vectors for analysis. Vector quantities contrast with scalar values such as mass, area, or speed, which have a magnitude but not direction. When dealing with vectors in equations, engineers commonly denote something as a vector by putting an arrow over the variable. Variables without an arrow over top of them represent a scalar quantity or simply the magnitude of that vector quantities. Okay, to represent a vector quantity, we will generally have two options. These two options are magnitude and direction. This is for the first one, magnitude and direction form, where the magnitude is given as a single quantity and the direction is given via an angle or combinations of angles. Okay, the second one is component form, where the magnitude and direction are given through component magnitudes in each coordinate directions. The magnitude and direction form of vector quantities are often used as at the start and end of the problem. This is because it is often easier to measure things like forces and velocities as a magnitude and direction at the start of a problem. And it is often easier to visualize the final result as a magnitude and direction at the end. Vectors represented as a magnitude and direction need to be shown visually through the use of an arrow, where the magnitude is length of the arrow and the direction is shown through the arrowhead and an angle or angles relative to some known axis or the other direction. Okay, after this I will pass my slide to Lawrence. Lawrence?
Okay, thank you the sharing of Bernard. Now is mathematical solution with drawing. From the picture, we can see a stair and floor. We can use dot product that we learned in chapter 5 that which is vector and scalar to find the degree between stair and floor. That is angle between A and B. Next. Solution is, so vector A is 3i plus 4j and vector B is 5i minus 2j. Solution is A dot B equals to open bracket 3i plus 4j close bracket dot open bracket 5i minus 2j close bracket. The dot mean is times. So we just need 3i times 5i plus 4j times negative 2j. It will equals to 15i squared plus 8j squared. If got square, we replace I squared and j squared to 1. So 15 times 1 minus 8 times 1. Answer will be 7. Next, we use the formula which is cos theta equals to A dot B over magnitude A times magnitude B. Just now we already got the answer of A dot B which is 7. So now we need to find magnitude A and magnitude B. Magnitude A which is square root 3 square plus 4 square. The answer will be 5. Magnitude B which is square root 5 square plus open bracket negative 2 cross bracket square. Answer will be 5.39. So now we just put the answer in formula, which is cos theta equals to 7 over 5 times 5.39. It will be cos theta equals to 0.260. So now we just put cos to right, it will be inverse cos times 0.260. So final the degree between stair and floor will be 74.93 degree. Thank you. That's all for me. I will pass it through my next friend.
So the conclusion is, in this topic, a vector directed in two dimensions has two components, that is, an influence in two separate directions. The amount of influence in a given direction can be determined using methods of vector resolution. That's all. Thank you.